Assalamualaikum and very good evening. My name is Mohamed Ruzaini bin Mohamed Jamil. I'm from UR 652 3008 and my number metric is 2013 92848. Today I want to present and I want to discuss about lab 1, operational amplifier, inverting and non-inverting amplifier. Firstly, I want to show the circuit that I made from multi-sim live. Firstly, the inverting amplifier. Inverting amplifier that I made is like this. First, we have RF equal to 4.7 kilovolt. So, first I get the voltage gain is negative 4.7 volt. And how I get the voltage gain is like the formula I calculate, and it seems like this. Negative 4.7 K over 1K, and it's equal negative 4.7 volt. This is the AV or voltage gain. Next, how I get the V out. V out is equal voltage gain times voltage in. My voltage in is 600 and 0.42 millivolt. So my V in 600 and 42 millivolt. The formula is V out equal to voltage gain times V in. So I times these two is equal to negative 2.822 volt. From the circuit, I get negative 2.8271 volt. So it's accurate lah, accurate. Seems like the next circuit is still same under the inverting op amp, but change the RF. RF is equal to 10 kilovolt. So how I get the value is like how I show this calculate. The formula is still same, and I get my V out is negative 6.6718 volt for the calculate. And for the experiment, I got negative 6.6826 this in the circuit. Still accurate lah. Oh, forget lah. The waveform is like this. Next, the RF equal to 33 kilovolt. So it still same the formula. I just change the RF and I get negative 4.3715 volt. And in the circuit, I got negative 4.3834 volt. And the waveform show like this. Okay, next. The question, why the output waveform has been clipped? So, from this, I can answer if the input times the gain of the op amp greater than the supply rail, then clip occurs. First, what that I understand, uh, the clip means this in the waveform, or what they call cut. If this were an ideal op-amp, then the output would be 30 volts in sine wave. Since the rail are between positive 5 volt, as soon as the output reach a voltage greater than 5 volt eclipse. So that's why the waveform like this is been cut lah. Second, why is called an inverting amplifier? The answer is the op-amp change the phase angle of the output signal exactly 180 degrees out of phase with respect to input signal. Next, non-inverting operational amplifier. So the circuit like this and the formula like this. Just change a little bit. The voltage gain 1 plus Rf over R1. So for the 4.7 kilovolt, the voltage gain I get 5.7 volt, and I calculate the value is negative 803.13 millivolt, and the value from the circuit is negative 808.8 millivolt. And the circuit and the waveform show like this. Same like this, just change RF equal to 10k volt. So voltage gain I get 11 volt, and V out I get 10.883 volt. From the circuit I get 10.767797 volt. Next is RF equal to 33 kilovolt. I get the voltage gain equal to 34 volt, and V out equal to 10.95 volt. And the value from the circuit is 10.058 volt. The waveform 33k inverting and non-inverting is like this. It have the clip, so the waveform show like this lah. Like that lah. The question, why it is called a non-inverting amplifier? It doesn't invert the phase of the signal. So the conclusion that I will make, I learn how to demonstrate an inverting op-amp and non-inverting op-amp circuit using the multi-stream live. And secondly, I know to investigate the op-amp voltage follower. So that's enough for me. Thank you.